It has been estimated that between 2000 and 2012, over 800,000 people have died as a direct consequence of earthquakes around the world. That's about 60,000 people every year, twice the student population of this university. Now, there are a number of methods that are used to help find survivors of these situations. These include sniffer dogs, cameras on the end of sticks, or even using microphones. But these are all affected by range. However, one solution that is starting to be used more and more around the world is the use of robotics to reach where nothing else can. So at this point, I'd like to introduce you to Wormbot. Wormbot has been developed here at the University of Leeds and is one of a growing number of snake or worm-like robots being developed around the world. With a long, thin body, you'd think it'd be ideal for getting into small gaps, like in rubble. Well, not quite. It's quite large, this. It's about the width of a rugby ball, or my head. Now, a rugby ball isn't even going to fit through railings in a fence, and I'm not going to go and stick my head in a fence to see if it fares any better. However, one of the other problems are its joints. They need to be stretchy to allow it to be able to maneuver itself around other obstacles. So that's what I've been working on. I've been working on stretchy joints that can be downscaled. And we've had a bit of luck here. What we've found is we are able to produce these joints, but we can produce them to stretch to a predetermined amount, which is great, because no two buildings are ever going to collapse the same way. You need to have something that's adaptable. Let's take, for example, the University Union building. It's going to be developed soon, redeveloped, but imagine halfway through, it collapses. We can send Wormbot in to have a look around, and he does pretty well until it gets to one of the bars. In Old Bar, all the damage has completely destroyed the bar taps, and they have caused Old Bar to flood with beer. Bit of a weird situation, but bear with me. What you can do is you can take the robot out. You'd be able to 3D print a joint that would be suitable for swimming, fit it in, and send it on its way. It's like buying a new bike tire instead of replacing the whole bike. And we hope this adaptableness has the potential to save lives. So, what we hope to do in the future is we want to further develop these joints. We want to make them more robust. We want to make them more predictable. But what we also want to do is we want to simulate how they'll behave in different environments to see which will do best with which job. We may even find which joint would be best to swim in a river of beer. Ladies and gentlemen, thank you very much.